Welcome back, builders and engineers, to another episode of our Minecraft civil engineering series. Today, we're talking about something vital to any construction projects: stormwater management. In civil engineering, stormwater management is all about controlling rainwater and runoff, ensuring it doesn't cause problems like flooding or erosion. And we have a few points of topic. We want to understand the water cycle and runoff, designing drainage systems, retention ponds and detention basins, and finally, green infrastructure and permeable surfaces. And you've probably heard of some of those before. So let's go ahead and dive right in. So first and foremost, it is important to understand what the water cycle is and how it affects our surrounding area. So you may have all learned through your time at school that the water cycle is comprised of 4 different sections. That is evaporation, condensation, precipitation, and collection. The biggest 2 factors that we need to consider in engineering are the precipitation and the collection. Precipitation is all about the volume and the length, or the duration of a storm event. Often when designing things in engineering, there are some key factors when it comes to stormwater quality. We're often designing builds to withstand the 1, 2, 5, 10, and even the 100-year storm event. And just as it suggests, the 1-year storm event is pretty minimal. The 2-year, the 5-year, the 10-year is where we start getting into the realm of needing to develop the proper facility management of that water. And then the 100-year event is the largest storm event, which is often on a natural disaster level. And we want to make sure that all of our stormwater facilities, our ponds, our networks can withstand the volume of water and the time that it falls. And you can see to my left and right here a couple curb gutters in our road. This is often you'll see driving down the road, you'll have these little slits along your curb, which is the barrier from the road to the sidewalk. This is where stormwater is collected from roadworks. Often water is running transversely along the roadway and enters these systems, where then it is then carried out through some sort of network and either down into a tributary water source like a pond, lake, or river, or into a stormwater detention or retention pond that we'll get to later. And if you don't remember from the last one, we also have a cross section of a road, and roads actually do have about a 1.5% slope in each direction, so the water should never puddle on the crown or the center point of your road. So as I mentioned before, in real life, rainwater either gets absorbed into the ground, evaporates, or flows into natural bodies like rivers and lakes. However, when we develop land, building roads and houses and cities, we reduce the area where water can naturally infiltrate into the soil. This leads to what's called runoff, where water flows over the surface and potentially causes flooding or soil erosion. Notice the red arrows above me on this little cross section we have of this hillside. Typically, in this first instance, water will permeate through the surface and some of it will still naturally roll off. When we go back and we develop this area, and now it is something like concrete or a building, the water has no way of permeating through the soils and dispersing and such. Rather, there is more runoff, which can lead to further problems. And we can show how this works with a simple bucket of water. Take those long flowing wheat, carrot, potato fields that you've worked so hard to get to your hardcore series, and imagine if runoff existed in Minecraft. Well, it would look a little something like this. Complete and utter destruction of your fields. And in a serious event, much as the 100-year storm event, something much more sinister could happen. Like your home could be completely buried in water. And now you may be asking yourself, so how do we prevent or control these issues? Well, let's jump into section 2 and find out. So how do we prevent problems like this from occurring? Well, the first tool in our stormwater management toolkit is the drainage system. In the real world of civil engineering, drainage systems are designed to channel water away from roads and buildings to prevent the flooding. We use things like I described before, like gutters and storm drains and underground pipes to direct the water to safer locations. Just like in our village that we did a few episodes ago, all of the water in the runoff in this location, most of which is going to be either in this detention pond in this area, or the detention pond here, or completely removed from the area via underground storm drain systems to the existing water surfaces that you see around the area. Now, some of this will run off naturally, like any rain that falls in this general area will eventually find its way down and into the existing body of water. However, in these areas where we've created impermeable surfaces being surfaces that water cannot penetrate through, such as our roads or our buildings, the water is going to have to meander its way through certain areas and find the depression areas or the low points, and that is where it's going to pond. In Minecraft, we could design drainage systems by using like channels or underground water tunnels. Here, by digging a simple trench along our crops, we now have given a guide or a mechanism for the water to follow in order to completely avoid the destruction of our crop fields. So, in the same fashion as before, and the water in the same location, you can now see that the water will not destruct our crops, but instead will flow evenly dispersed throughout this drainage channel. A trench like this acts like a real-life storm drain, capturing runoff from the road or the nearby area, channeling it away from our structures, our fields, or anything else we're trying to avoid. So now let's jump back into our little village layout here. And we're going to jump into the next section, which is retention and detention ponds. Now, you may be asking yourself, what is the difference between a retention and a detention pond? Well, let me describe that to you. Both retention and detention ponds are designed to manage the stormwater, but they function in slightly different ways. For a retention pond, the primary purpose is to hold the water permanently. They have a permanent pool of water that helps manage stormwater over time. Similar to a lake or a pond, they always maintain water with the additional capacity to temporarily store runoff during and after rain events. As for their function, they manage the water quality by slowly releasing the water through a controlled outlet, but also improve the water quality by allowing pollutants to settle to the bottom and the vegetation around to help with the filtration. Typical uses of a retention pond are in areas where water needs to be retained for longer periods, like in developments with space for water features, such as the one here. Now, a detention pond, as I said before, is pretty similar to a retention pond. However, they are designed to temporarily hold water during and after storm events and then release it at a controlled rate. So normally the detention pond is typically dry during all times of the year except for or immediately after a rain event. It fills up during the storms and slowly releases water throughout a structure outlet, similar to the retention pond. And another use for this would be in urban areas or places where immediate drainage control is needed without permanent standing water. Now, sometimes this is up to the jurisdictional agency whether you use retention or detention, but in the case that either is an option, it comes down to the developer, whether or not they want to have a standing body of water for the aesthetic appeal, or if they just want to have a grass swale or some sort of soft, dry bottom basin, that is totally up to their discretion. But in both situations, they need to make sure that it can maintain the 100-year storm event to prevent destruction. So in Minecraft, though it isn't important to have stormwater management facilities like retention and detention ponds, they do add an aesthetic appeal to your build. And also adding some plants around the pond create a natural buffer zone. In the real world, these plants help filter out pollutants and improve the water quality. And in Minecraft, it adds that nice aesthetic touch while reinforcing the pond's role in stormwater management. So hopping back to our lovely gas station example here, we're going to go ahead and touch on the green infrastructure. In civil engineering, the green infrastructure is all about working with nature to manage storm water. This includes things like permeable pavements and green roofs and rain gardens. These techniques allow water to infiltrate the soil rather than becoming runoff. And as previously mentioned in another episode, we went ahead and added what is a makeshift area for a green roof here. Now, you may or may not have seen what a green roof or a rain garden is, but for example, take this little green splotch here in the corner of our gas station roof. If we pretend that most of this is impermeable, once again, water cannot infiltrate this. This is some sort of barrier canvas for the roof of our gas station. All the water can make its way over to this area here, which is the green roof or green infrastructure. This allows for the plants and other things to clean the water, improving the water quality, but also allow it to permeate through down below and then probably through some sort of underground infrastructure or pipe network where it eventually falls through a gutter and down into the remaining stormwater management infrastructure, which is some sort of storm sewer along a road network or a nearby retention or detention pond. And similarly, we have the permeable pavement that we used here in an example to show what it is like for the exact same feature as the green roof, although with these, it's not about aesthetic, it's just about controlling the water. Typically, this will be brick pavers or some sort of permeable pavement. They actually make asphalt and concrete that water can permeate through. Would you look at that? So by mixing permeable surface like grass and dirt and hard materials like stone, we can reduce the amount of water that becomes runoff. It's a simple, effective way to manage stormwater while our Minecraft builds look great. Now, just for some symbolic references, obviously these are going to be a little overscaled, but you can imagine that all the water in a rain event is making its way through our rain garden. Now, typically this could be the entire rooftop, or just a single section where most of the water runs to. But eventually, after all of the plants or vegetation in this area are saturated enough, the leftover water will then come down some sort of gutter system. Now, obviously, that's not going to work because now our guy can't get fuel. But it will continue down into an underground system. But as we touched on in utilities before, this will eventually make its way out into the storm infrastructure that runs along the road, kind of where the curb and gutters are attached to. Or it might make its way out into a retention or detention pond, which will eventually flow into a storm system or into the natural bodies of water around. Same thing with the permeable pavement. It will permeate most of the water that it can into the soil or the mediums beneath, but eventually, over time, that will become oversaturated and an underlying drainage pipe, usually a perforated plastic pipe, will be beneath the permeable surfaces and capture any of the excess flow, and then, you've guessed it, connects back into the system, which water can't travel uphill, so it'll be probably down here. Now, putting it all together, from drainage systems to retention ponds to green infrastructure, we can apply real-world engineering concepts to prevent flooding and keeping our buildings safe and functional. While Minecraft's water mechanics may not fully reflect the complexities of real-life hydrology, the principles remain the same. Control the flow, reduce the runoff, and work with nature. By incorporating these techniques into your Minecraft builds, you can create not only a more realistic city, but also a more sustainable and functional one. So thanks for joining me on this deep dive into stormwater management. Don't forget to like, comment, and subscribe for more episodes in our Minecraft Civil Engineering series. Let's keep building a better world, one block at a time. Happy building, everyone. Goodbye.